The Tibetan Plateau, also known in China as the Qinghai-Tibet Plateau or Himalayan Plateau, is a vast elevated plateau in Central Asia or East Asia, covering most of the Tibet Autonomous Region and Qinghai Province in western China, as well as part of Ladakh in Jammu and Kashmir state of India. It stretches approximately 1,000 kilometers north to south and 2,500 kilometers east to west. With an average elevation exceeding 4,500 meters, the Tibetan Plateau is sometimes called the roof of the world, and is the world's highest and largest plateau, with an area of 2,500,000 square kilometers. Sometimes termed the Third Pole, the Tibetan Plateau is the headwaters of the drainage basins of most of the streams in surrounding regions. Its tens of thousands of glaciers and other geographical and ecological features serve as a water tower storing water and maintaining flow. The impact of global warming on the Tibetan Plateau is of intense scientific interest. Description: the Tibetan Plateau is surrounded by massive mountain ranges. The plateau is bordered to the south by the Himalayan range, to the north by the Cumberland range which separates it from the Tarim Basin, and to the northeast by the Qinghai range which separates the plateau from the Hexi Corridor and Gobi Desert. To the east and southeast the plateau gives way to the forested gorge and ridge geography of the mountainous headwaters of the Salween, Mekong, and Yangtze rivers in western Sichuan and southwest Qinghai. In the west the curve of the rugged Karakoram range of northern Kashmir embraces it. The Tibetan Plateau is bounded on the north by a broad escarpment where the altitude drops from around 5,000 meters to 1,500 meters in less than 150 kilometers. Along the escarpment is a range of mountains. In the west the Cumberland Mountains separate the plateau from the Tarim Basin. About halfway across the Tarim the bounding range becomes the Altona, and the Kunluns, by convention, continue somewhat to the south. In the V formed by this split is the western part of the Qidam Basin. The Altona ends near the Dangjin Pass on the Dunhuang-Golmud Road. To the west are short ranges called the Danyi, Yima, Shul and Tulai Nanshan. The easternmost range is the Qilin Mountains. The line of mountains continues east of the plateau as the Qinghai Mountains which separate the Ordos region from Sichuan. North of the mountains runs the Gansu or Hexi Corridor which was the main Silk Road route from China proper to the west. The plateau is a high-altitude arid steppe interspersed with mountain ranges and large brackish lakes. Annual precipitation ranges from 100 to 300 mm and falls mainly as hailstorms. The southern and eastern edges of the steppe have grasslands which can sustainably support populations of nomadic herdsmen, although frost occurs for 6 months of the year. Permafrost occurs over extensive parts of the plateau. Proceeding to the north and northwest, the plateau becomes progressively higher, colder and drier, until reaching the remote Qianxiang region in the northwestern part of the plateau. Here the average altitude exceeds 5,000 meters and winter temperatures can drop to 40 degrees Celsius. As a result of this extremely inhospitable environment, the Qianxiang region is the least populous region in Asia, and the third least populous area in the world after Antarctica and northern Greenland. Geology and geological history. The Himalayas are among the youngest mountain ranges on the planet and consist mostly of uplifted sedimentary and metamorphic rock. According to the modern theory of plate tectonics, their formation is a result of a continental collision or orogeny along the convergent boundary between the Indo-Australian plate and the Eurasian plate. The collision began in the Upper Cretaceous period about 70 million years ago, when the north-moving Indo-Australian plate, moving at about 15 cm per year, collided with the Eurasian plate. About 50 million years ago, this fast-moving Indo-Australian plate had completely closed the Tethys Ocean, the existence of which has been determined by sedimentary rocks settled on the ocean floor, and the volcanoes that fringed its edges. Since these sediments were light, they crumpled into mountain ranges rather than sinking to the floor. The Indo-Australian plate continues to be driven horizontally below the Tibetan Plateau, which forces the plateau to move upwards. The plateau is still rising about 5 mm per year. Animal and plant life. Tibet's elevation and lack of precipitation produces an alpine tundra environment, which reduces species diversity. Tibet hosts species of wolf, wild donkey, cranes, vultures, hawks, geese, snakes, and buffalo. One notable animal is the high-altitude jumping spider, that can live at over 6,500 meters of elevation. Nomadic culture. Nomads on the Tibetan Plateau and in the Himalayas are the remainders of nomadic practices historically once widespread in Asia and Africa. Pastoral nomads constitute about 40% of ethnic Tibetan population. Their presence was made possible by the adaptation of nomadic people to survive on the world's grassland by raising livestock rather than crops which are unsuitable to the terrain. Archaeological evidence suggests that the colonization leading to the full-time occupation of the plateau occurred much later than the previously thought 30,000 years ago. Impact on other regions. Role in monsoons. Monsoons are caused by the larger amplitude of the seasonal cycle of land temperature compared to that of nearby oceans. This differential warming happens because heat in the ocean is mixed vertically through a mixed layer that may be 50 meters deep, through the action of wind and buoyancy-generated turbulence, whereas the land surface conducts heat slowly, with the seasonal signal penetrating perhaps a meter or so. Additionally, the specific heat capacity of liquid water is significantly higher than that of most materials that make up land. Together, these factors mean that the heat capacity of the layer participating in the seasonal cycle is much larger over the oceans than over land, with a consequence that the air over the land warms faster and reaches a higher temperature than the air over the ocean. The hot air over the land tends to rise, creating an area of low pressure. This creates a steady wind blowing toward the land, bringing the moist near-surface air over the oceans with it. Similar rainfall is caused by the moist ocean air being lifted upwards by mountains, surface heating, convergence at the surface, divergence aloft, or from storm-produced outflows at the surface. However the lifting occurs, the air cools due expansion in lower pressure, which in turn produces condensation. In winter, the land cools off quickly, but the ocean keeps the heat longer. The hot air over the ocean rises, creating a low-pressure area and a breeze from land to ocean while a large area of drying high pressure is formed over the land, increased by wintertime cooling. Monsoons are similar to sea and land breezes, a term usually referring to the localized, diurnal cycle of circulation near coastlines everywhere, but they are much larger in scale, stronger and seasonal. The seasonal monsoon wind shift and weather associated with the heating and cooling of the Tibetan Plateau is the strongest such monsoon on Earth. Glaciology, the Ice Age and at present. Today, Tibet is an important heating surface of the atmosphere. However, during the last Ice Age AC, 2,400,000 square kilometers ice sheet covered the plateau. Due to its great extent, this glaciation in the subtropics was an important element of radiative forcing. With a much lower latitude, the ice in Tibet reflected at least 4 times more radiation energy per unit area into space than ice at higher latitudes. Thus, what at present adds heat to the atmosphere subtracted it instead. This cooling had multiple effects on regional climate. Without the thermal low caused by heating, there was no monsoon over the Indian subcontinent. This lack of monsoon caused extensive rainfall over the Sahara Desert, expansion of the Thar Desert, more dust deposited into the Arabian Sea, and a lowering of the biotic life zones on the Indian subcontinent. Animals responded to this shift in climate, with the Javan roosa deer migrating into India. In addition, the glaciers in Tibet created meltwater lakes in the Qīngzàng Basin, the Tarim Basin and the Gobi Desert, despite the strong evaporation caused by the low latitude. Silt and clay from the glaciers accumulated in these lakes. When the lakes dried at the end of the Ice Age, the silt and clay were blown by the downslope wind off the plateau. These airborne fine grains produced the enormous amount of loess in the Chinese lowlands. Since the end of the Ice Age, Tibet has risen at approximately 10 mm per year, at the same rate as the Himalaya. While the Himalaya rise can be explained by plate tectonics, the rise of Tibet can be explained as the isostatic rebound of the crust rising after the weight of the ice was removed. The amount of isostatic rebound since the last Ice Age is approximately 650 meters. Effect of climate warming. The Tibetan Plateau contains the world's third largest store of ice. Qianxiang, the former head of the China Meteorological Administration, said that the recent fast pace of melting and warmer temperatures will be good for agriculture and tourism in the short term, but issued a strong warning. Temperatures are rising 4 times faster than elsewhere in China, and the Tibetan glaciers are retreating at a higher speed than in any other part of the world. In the short term, this will cause lakes to expand and bring floods and mud flows. In the long run, the glaciers are vital lifelines for Asian rivers, including the Indus and the Ganges. Once they vanish, water supplies in those regions will be in peril. In popular culture, Zhang Qianxiang composed a song about the Tibetan Plateau, named Eey, which is performed by both Han Hong and subsequently by Russian singer Viters. In the Teen Titans animated series, the superhero Jericho lives atop a mountain in Tibet, living an isolated lifestyle. However, Jericho only appeared on his mountain in one episode. See also, Geography of Tibet, Geology of the Himalaya, Changtang, Taklamakan Desert, Yunnan Guizhou Plateau, Lop Nur, Kingdom of Tibet, Notes. References, Hopkirk, Peter. Trespassers on the Roof of the World, The Secret Exploration of Tibet. J. P. Tarcher. ISBN A0-87477-257-5 Brantingham, P. J. and Crossing, G. Peopling of the Northern Tibetan Plateau. World Archaeology 38, 387 414 doi, 10.1080/004382406008133001 External links, ON thinner ice AA plus or minus theta degree, The End of Earth Summer, Long Rivers and Distant Sources, Roof of the Earth offers clues about how our planet was shaped, Plateau Perspectives, Leaf Morphology and the Timing of the Rise of the Tibetan Plateau, Today's Weather in the Eastern Changtang, Protected Areas of the Tibetan Plateau Region, North Tibetan Plateau Cumberland Mountains Alpine Desert. Terrestrial ecoregions. World Wildlife Funder, Photos of Tibetan Nomads, Roof of the Earth offers clues about how our planet was shaped, Contemporary Lifestyle and Language Learning Center from Tibet Lhasa, the official language of Tibetan podcast.